We now move to the third beam, which is the continuous beam with an overhanging cantilever of 1.5 meters. You can see that this beam, we have the same bar mark 1 because the size of the links is the same. The size of the links is the same since the width and the length of the beam, the width and depth of the beam is the same. So we have the same bar mark 1, you see 10, but now the total number is 29 here because the length is not the same. Here we have 22, we have additional 1.5 meters, which give us 7 numbers. So that's why the total number here is 29. So the same shape and size. So adding this total number together, we have 1390. So multiply by 29, you have 40.31. So and then for the longitudinal bars, we have two different bars. We have the same bar at the top reinforcement, but because this is a cantilever beam, it has a cantilever end, there's an additional reinforcement at the top. So this additional reinforcement have this shape. So this is the shape here. You measure the length and then the anchor. So if you do that, the total number of that additional bar is 316, but the bar mark is 5. While the bar mark for the longitudinal reinforcement, the longer one, the bar mark is 04. So we make the records, and at the end of the day, we have our bar bending schedule. So, but what is important for the quantity surveyor in this bar bending schedule, what we've done is the engineer's part. We also need to calculate the quantity of reinforcement based on this, because this shape is what the iron benders we use to cut the length of reinforcement, all these shapes. But we need to also calculate the total number so that the QS can just come to your bar bending schedule and read the total number of 10 mm reinforcement, total number of 16 mm reinforcement. To calculate the total number of 10 mm, we need to add up 10 mm in beam 1, 10 mm in beam 2, 10 mm in beam 3. So addition of all of this will give us this total length here, 101.47. You can see that it is the same. So we are going to arrive at the same thing.